Okay, version 3, second video. Let's see here. Now we're into the APR standard, arithmetic with polynomial and rational expressions. The only one where you don't change the sign is the remainder theorem. If they're asking you to evaluate a polynomial at a value, say, okay, I'm going to use that value. Okay? And this simple algorithm of synthetic division, you got to remember it's drop the first one, multiply, add, multiply, add, multiply, add, so on and so forth. The remainder is the value. Okay? Now down here it just says add or subtract. I had a lot of students on this one and on the version 4 try to solve for x. That's not what the instructions are. The instructions are just to add or subtract. These are not like denominators, so we have to find a common denominator. And you have to correctly remember how to change each fraction to get them all over the same common denominator, and then just add or subtract the numerators, common or like terms. Okay? Down in the structure, I'll show you on the version 4 test a different algorithm for how to factor this out. But you got to remember magic x, drop the b, a times c, find your factors, then divide by a, reduce, and then write your binomials. Vertex form again is has h and k in it. It's just straight split it, square it, add it, and move the k back over to this side. Down here for the SRT, the stuff from topic 7, this one was straight set up, easy peasy, just correctly use the law of sines. Using the law of sines, again, you just set up one proportion. And how do you solve proportions? What did I say in the other video? Cross multiply. When you cross multiply that and then divide again by 48, this is a number. It's a number between 0 and 1. It's a decimal. You take inverse sine to find the angle. The sum and difference formulas. 15 degrees, well, one way to get to 15 degrees is say, okay, 15 is 60 minus 45. So take the cosine of 60 minus 45. Using the formula correctly, you'll have the formula sheet, but you have to have the unit circle memorized to get the exact answer. About 85% of my students just type this into the calculator. That's true, that's an approximate answer, but the instructions are find the exact value. The only way to find the exact values is to use these sum and difference formulas and express the answer as that fraction right there. Turn the page. The airport problem was designed to be used for law of cosines. Law of cosines, and this one is tough because PEMDAS could really jump up and bite you. A lot of students made the incorrect order of operations. And also, this is an obtuse angle. If we remember on the unit circle, if I have an obtuse angle, what's the cosine? What's the x-coordinate going this way? The x-coordinate is negative. It's going to make this, when I'm subtracting this negative, it's going to mean positive. That's where a lot of students messed up to. To get to the square root of that is 115.2 miles. The last one, the flag problem is just the Talisa shadow problem with a person standing. So if I covered up this part of the problem, doesn't that look like the Talisa shadow problem? It is. It's exactly the Talisa shadow problem. You just have to be able to interpret the verbiage and draw a good picture and just add the person's eyeball height to the Talisa shadow problem. Lastly, I try to instruct you guys to use the quotient and reciprocal identities and get everything in terms of sine and cosine. Students who did that found this one out quite easily. Students who did not follow my advice here flailed on this one or just gave up and didn't try it at all. All right, that's the end of that video.